topic 2 is on exploratory data analysis and feature engineering. This particular segment, I'm going to share with you what is EDA, why need to know the shape of the charts, steps for EDA, and that there are different types of variables. What is exploratory data analysis? In statistics, exploratory data analysis is an approach to analyzing data sets to summarize their main characteristics, often with data visualization methods. Exploratory data analysis has been promoted by John Turkey since 1970 to encourage statisticians to explore the data and possibly formulate hypotheses that could lead to new data collection and experiments. EDA focuses on checking assumptions required for model fitting and hypothesis testing, and handling missing values and making transformations of variables as needed. So this is the official reference below. You may ask yourself, why need to know exploratory data analysis? The objectives of EDA are as follows. Number one, it is to discover the shape or characteristics of your data sets. You want to find out, are there natural clusters of data? Which fields seems to be related or unrelated to each other? EDA provides some clues about interesting aspects of your data set that warrants deeper investigation or more data collection. You wish to find out whether are there some visible trends or are there any missing data from your data collection. Why is there a need to know the shape of the charts? To Mark, he says, doesn't statistics tells us everything we need? To him, they are lies, damn lies. To Mark, he finds that statistics alone is not able to justify an opponent's point. You really need to know the shape of the charts. XCOMBI's quartet comprises 4 datasets. These 4 datasets have the nearly identical simple statistical properties, yet appear very different when crafted. Each dataset consists of 11 points, and they are constructed in 1973 by the statistician Francis Enscombe to demonstrate both the importance of crafting data before analyzing it and the effect of outliers on statistical properties. Here are the 4 datasets. This is the first dataset and all the values. The second dataset, all the values. The third dataset and all the values. And the fourth dataset and all the values. These 4 datasets, they have similar properties and values, whereby the mean of X in each case is 9. Sample variance of X in each case is 11. Mean of Y in each case is 7.5. Sample variance of Y in each case is 4.12. Correlation between X and Y in each case is 0.816. And the linear regression line in each case is Y equals to 3 plus 0.5X. When you draw charts using these 4 sets of data, they look so different. Figure 1a, the first scatter plot top left appears to be a simple linear relationship corresponding to two variables, where y could be modeled as Gaussian with mean linearly dependent on x. Let's look at figure 1b. The second graph, top right, appears to be not a linear relationship between two variables. Let's look at figure 1c. The third graph, bottom left, the model relationship is linear. The regression is offset by the one outlier which exerts enough influence to lower the correlation coefficient from 1 to 0.816. And look at figure 1d, the fourth graph, bottom right. The data points do not indicate any relationship between the variables. There is one outlier, one extreme x value that resulted in high correlation coefficient, even though the other data points do not indicate any relationship between the variables. So 4 data sets, 4 different charts. Therefore, it is important to understand the statistics and also know the shape of the charts. Steps in EDA, assuming that we wish to measure employee engagement. So what we have to do is we will need to get the raw data, perhaps from survey forms, and then we need to import the data using Python programming, and then we need to cleanse the data. After that, we do data transformation, we draw charts, and we will then gather the insights. And then we will then share our final insights or results with our employees. So this is the entire process, data wrangling process. Read in the data, import the data, and cleanse it. And after that, you will draw charts, and then you gather all the insights and you communicate your final results with your employees. There are two different types of variables. You have numerical variables and categorical variables. So numerical variables, you have discrete variable and continuous variables. Categorical, you have nominal, ordinal, and time variables. Discrete variable is a variable that may contain whole numbers. Example, number of items bought by a customer in the supermarket can be 1, 2, or 10 items. Number of pets in the family can be 1, 2. It cannot be 1.3 pets. Continuous variable is a variable that contains any value within some range. For example, the total amount paid by a customer in the supermarket is continuous. This customer can pay $32.50 and $100.60. Another example is the price of the house, where you can take any value within the range. It can be, $2 million for the house or 500K for the house. Time spent serving a website can be variables are selected from a group of categories. And there are two types. You have nominal variable and ordinal variable. Nominal variable is a variable with no specific order. Example, male, female. Marital status can be single, married, divorced, or widowed. And intended use of loan can be, the loan is actually to purchase a car, or the loan is actually for house renovation. Ordinal variable is a variable in which categories can be ordered. For example, student's grade in exam can be A, B, or C. Days of the week, Monday equals to 1, Tuesday equals to 2. And then education level, primary, secondary, polytechnic, or university. Let's try this quiz. What is a discrete variable? Choose one answer from here. Let's try quiz 2. Identify an example of continuous variable. Choose one answer from here. Thank you for listening. For this part, I have shared with you what is EDA, why EDA, steps for the entire data wrangling process. And then I also shared with you that there are two types of variables. Thank you very much.